So I want to do a quick introduction. I know I met some of you guys in your office. I'm Bryan Berkley with Viking. I've been with Viking for 9 years. It's going on 9 years. We just recently changed some roles. So before we get into the obstruction class, I want to let you know the change in Viking. So for the last 7.5 years, I handled engineering firms primarily and AHJs. And I work with you guys on specifications and working with fire departments, fire marshals, AHJs, keeping them up to date on codes, things of that nature. Back in January, and during that time, we had Viking and we had Minimax. So Minimax was fire suppression, clean agents, things of that nature, and Viking obviously was foam and all that. Well, what we decided back in this past January, our corporate office decided that they were now going to rebrand Minimax back over to Viking, and we're going to make a Viking Special Hazards folder. Inside of that folder is inside of that division of Viking Special Hazards is now 2 folders. So we have Viking Foam as a Special Hazards, and now we have Viking, we rebranded Minimax back over to Viking, and now we have a folder for Viking Special Hazards. So my boss came to me in January and said, hey, since you have the experience with this stuff as a contractor, before I came to Viking, I was a contractor design manager. I want you to manage the East Coast, and you're going to change your role a little bit. Not only are you going to still see engineers, but you're now going to be involved in the sales. So lately, I have not had the opportunity to come into the engineering firms because I've been focused on getting the sales correct, sales numbers correct. I got to, all the inside stuff on sales side of it. So, I will be coming back into the offices here soon with engineering, getting in to see you guys. When I do spend time with you guys, I'm still your point of contact for sprinkler heads, valves, foam, clean agent, and all that. You can still ask me any question. I'm your main point of contact here, even though I live in Delaware. I cover the whole East Coast. But moving forward, I'm going to be, my first few things is going to be talking about special hazards, clean agents, foam systems, things like that. But I can still answer any question when it comes to sprinklers and so on. So you'll see today I'm doing a presentation on obstructions. I think November I'm doing a presentation on clean agents only, and then December I think I'm doing one on foam directly. So I do apologize, I do not have my PowerPoint up. I was working on my PowerPoint. I went to Puerto Rico on Sunday, and I was supposed to work Puerto Rico Monday, Tuesday, and Wednesday, and then come here Wednesday night. And I was working on my PowerPoint, finishing it and cleaning it up and making it updated to some of the updated codes. And then last night I went to go find it and my computer has disappeared on the computer. So not a big deal. So what I figured was instead of going in panic mode, we're just going to go through Nfpa 13 on obstructions today. Okay, and this might be the best way to go because if we have a question, please speak up and ask. So what my goal is today, we're going to go over residential, standard coverage, extended coverage, and storage. And we're going to go through the different obstruction requirements. And then afterwards, we have an obstruction, Sprinklermatic University here has a building back here that has live sprinkler heads with water. And we'll be able to flow, we'll be able to take what we read and go over today in the classroom, and we'll be able to actually physically see it happen out there. So we have some heads that are under obstruction. So when we flow the water, we're going to see why the obstruction, what it actually does to the flow of the sprinkler, and then we're going to be able to, so we'll be able to put them together. So for the first hour or so, we're going to be in here. We'll probably wrap up a little earlier than 11:30, but we're going to go ahead and do the classroom first, and then we'll go out there and flow. Okay. So like I said, we'll go ahead and we'll start off with the residential sprinklers. And residential sprinklers, whenever we need to do obstructions and we're looking at residential sprinklers, where do we go in Nfpa? Depends on the occupancy, right? So if we're talking about a single family house, we go to 13D. If we're talking up to a maximum of four floors, we go to 13R. But most of the work, and correct me if I'm wrong, but most of the work down here is going to be a 13 application. It's a high-rise building, a little bit over 4 stories probably. So we're going to follow NFPA 13 at that point. NFPA 13 specifically calls out residential sprinklers, and we know that still today there's a lot of engineering firms that don't specify residential sprinklers in these occupancies. They're either doing extended coverage or they're doing standard coverage commercial sprinklers. So in NFPA 13, they call out for residential sprinklers for a reason. Number one, you can save the pipe size on the residential floors. So let's say you have a multi-use building. Maybe you have some commercial on the first couple floors, you have apartments or condos on the upper floors, maybe you have a hotel in that building as well. In all the living areas, they want us to use residential sprinklers. You can do a 4-head calc rather than a 900 square foot remote area. You can use, you're still going to use the 0.1 density, but you're going to use CPVC pipe on them upper floors. By doing a 4-head calc, we're going to be able to lower the volume of water that's required, which is going to help lower our pipe sizes. So with that being said, when we get into residential sprinklers, we do have to do a couple things. We have to make sure that when we're looking at our design, where are we adding the sprinklers from the engineering? What do you guys, we have 2 different companies here, so what do we do on our specifications and our FP drawings? When we're doing drawings and specifications, do you guys show sprinklers on the drawings?
Sometimes we do.
Yeah. Sometimes you do, sometimes you don't. Sometimes we just say it has to be in accordance with NFPA 13.
Right.
Sometimes we leave it very plain, and then other times we might have to even go a little bit farther depending on the jurisdiction, right? So it's important to kind of understand that everybody thinks, sprinkler heads are all sprinkler heads. Well, that's not really true. Each type of sprinkler has its own obstruction requirements. So, like I said, we're going to start off with residential, and for obstructions with residential sprinklers, all of our obstructions are going to be under Chapter 8 in NFPA 13. Now, this is the 2016 edition, but if we go back, it's still Chapter 8 in NFPA 13, okay? The beginning of Chapter 8, it just talks about the basics of it. Then we're going to get into Chapter 10, which is sprinklers in residential occupancies. And why are we not there? All right, so the first thing is we got to remember that residential sprinklers you're going to follow the listings of all the manufacturers, okay? So of course I'm from Viking, but today we're not going to talk about specifically Viking. We're going to talk about sprinklers as a whole. So with residential sprinklers, all manufacturers, they're going to give you, whether it's a pendant, a sidewall, or an upright, the manufacturers are going to tell you guys as the engineers or the sprinkler contractors that the sprinkler head will cover this area, and at this area it's going to flow this much water at this certain pressure. Okay, all residential sprinklers are what we call fire tested to meet the requirements, where standard sprinklers and extended coverage sprinklers are not. Okay, they don't. When we come out with a new sidewall or standard coverage or a new extended coverage, we don't have to do a live fire test to prove our theory. We can just follow the NFPA 13. So the big thing is, keep in mind when we're doing residential sprinklers, the first thing is you're always going to fall back to the manufacturer's requirements of the listing and the spacing of the sprinkler head. So chapter 8.10, it's just pretty much telling us, the minimum distance, maximum distance. We're going to follow that through the manufacturer. You take half the distance and we go from there. The minimum distance with residential sprinklers, between sprinklers, the minimum distance is going to be 8. But once again, if we're going to follow a residential line and we're using the 20 by 20 spacing, Do we want to go 8? Probably not. Probably we're going to extend that out to a minimum of 10, half the distance of the area that it's covered. Keep in mind for residential sprinklers, when we get into slopes up here, okay, slopes are extended to only 8/12 pitch, okay. So we got to make sure that if we're using residential sprinklers, we need to know what the slope of that ceiling is going to be, because you can. I'm sorry, it's 4/12 pitch. It's not 8/12. So if you have a large slope ceiling, we might not be able to use residential sprinklers. We might have to go back to standard coverage or extended coverage. Deflectors on residential sprinklers are always going to be 1 to 4 inches down, or when we get into sidewalls, we can go up to 12, depending on the manufacturer's listings. Okay, some of the manufacturers only have listings down to 6 inches. So that's important to know when we're looking at drawings for you to specify a sprinkler head. If you have obstructions and you need to be lower down, we need to make sure that those sprinklers are listed to be lower down. Okay, so right now we're looking at upright and pendant. So for upright and pendant, it's 1 to 4 inches. We're going to skip through some of this stuff. These charts here right now, we're just talking about the slope ceiling over here on the side, the distance between sprinklers, how we measure them, and things of that nature. So are you guys going to get into this 100%? Probably not, but it's nice to know where you can find it if you're doing a review of a sprinkler contractor's drawings, to make sure that they have their heads spaced properly. Because nothing worse is when we approve, you guys do review drawings, calculations, and approvals, right?
Yes.
You review their submittals, cut sheets, and things like that. So it's important for us to know, okay, if we're looking at residential sprinkler heads, what is the actual slope, how are they sloping, and what is the spacing? So you'll see here figure 810 3.5 is going to tell us, that when you're going up the slope, you have to have a certain spacing, and then when you come at the top of the peak, you got to be 3 feet down of a maximum. And then you got to make sure that when you go up the peak and back down the peak to get to the 2 heads, you have it right. Most times we're not going to be following this because, like I said, most of our buildings that we're working with in the area are going to be 13 high-rise buildings. So what does that mean? It's going to be flat because there's another ceiling above. There's more floors above. So we're not going to spend a whole lot of time with the roofs. Because even on 13R buildings down here, they're pretty much flat roofs, right? That you don't really have a whole lot of A-frame roofs because of hurricanes and things like that. So we're going to skip over there. The location for the distance off of walls. Remember, 4 inches minimum, okay? You can't have a head any closer than 4 inches off of a wall. So what happens is if this is the wall, and if we have a head, if a contractor puts a pendant head up against the wall, why will that not activate?
Sensitivity?
Exactly. So if this is the trash can, and let's say the fire starts here, the heat's going to come up, it's going to hit here, and it's going to roll out. And we've proven on live fires that when it rolls out,
missing.
And if you're any closer than 4 inches, the good chance is there's a pocket here that's never going to actually heat up. That's an area that on most fires, unless the fire flashes over, it'll never burn the corners of a building or of a room. So that's how we came up with the 4 inches. So here's a big one here. This is 810-6. This chart here. This is a very common chart that we're going to use to verify obstructions, okay? What this is telling us is if you have an obstruction running down the center of this room, depending on how deep that obstruction is, will depend on how far away that sprinkler can be to flow under it. So do we have to add sprinklers on each side of obstruction, or can we just have one row of sprinklers that will flow under? So what we got to do is you got to take the distance from the bottom, deflector. Remember, this is always going to be from the deflector, not the ceiling.
Yeah.
Okay? So from the deflector to the bottom of the obstruction, we have to know that distance. And then we can look at the chart next to it, and that's going to tell us
B and A.
B and A. So if B is, so here we'll say, we'll see here, if it's 3 inches, you need to be 3'6", less than 4 feet, okay? If you go down even more, you'll see where it starts to build up, and now you got to be even farther away. So if you're 14 inches of B, which is from the deflector to the bottom of the obstruction, it's 14 inches, you need to be 7 feet away from that obstruction, okay? Now here's another one that we're going to see out here today. In residential, this is very common. Why would this guy right here be very common in residential applications? Where would we see something of this nature in... Oh, you're good. You good? Where would we see this application? Very common in residential applications.
And
Anybody tell me?
highlights?
Yeah, but what room specifically are you going to see this application? You're going to apply this rule to every...
Kitchen. Yeah.
Absolutely, the kitchen. Why is that? Just imagine that the blackened out piece that says obstruction. In the kitchen, a lot of times, what do? They put the cabinets up against the walls all the way around the kitchen, right? And then they'll put maybe a refrigerator underneath, or you got the stoves, you got countertops and all that. So this is this guide here is very common to use in every kitchen of every residential application. This is the same, these charts here are the same whether it's 13D, 13R, or 13, okay? So if we just think about it, there's your standard cabinet that's up high to the ceiling, and then underneath you're either going to have your counter space or your stove or a refrigerator. And we're going to see this out there today. So this one is a little bit more. You're going to notice there's a little bit more math to it, okay? So we still need to know what is the distance. Remember, whenever we talk obstructions in whatever standard, whatever type of sprinkler head we're looking at, we're always talking about from the deflector down. So in this one here, we need to know a couple things now. B, we'll start off with the B, because that's the most important part, is what is the distance down from the bottom of the obstruction to the deflector? And then also D, how wide is that obstruction? If that obstruction is over 30 inches, we have to put a sprinkler head under there. Okay? If it's not, if it's less than that, then as long as we can evaluate D and A, the distance off of the deflector to that wall, then we can make this sprinkler head flow underneath of that obstruction, which would be the cabinets. So how do we do that? You got to take D, take the dimension of D, minus the 8 inches, add B, and then where D is less than 30 inches, we're in good shape. We can now move that sprinkler head over, and we're now going to follow this same chart. But this is a very common, and when I go into, and I'm working with fire marshals, they get a lot of confusion on this, because there's a lot of times where sprinkler contractors don't think about, because how often do we show obstructions on our drawings, like the cabinets? Very rarely do our engineering drawings show the cabinets, right? So we have to, my opinion is, as engineering firms, we have to make a note in the kitchen area.
Provide cross sections.
Well, I'm not worried about providing cross sections, but if we make a note to the sprinkler contractors that says, follow obstruction figure 8.10.6.12, if we make a note there, now it's on the the designer of that sprinkler contractor. And if he misses it, and we go out at the end of the day, and we're ready to do a walkthrough, and realize that he has the head too close. Guess what? We did our job as the engineer, because remember, what does the engineer build our business off of? For the most part, we build our business off of reputation and repeat customers, right? So if we are making it clear to the contractors in certain areas where we know there's going to be obstructions, and at the end of the day, if they don't have the head right, and we approve the drawing, and now there's a change order because the drywall's done, everything's done, and now we got to go back and cut it. Is the end user going to be happy with us as the engineers?
Not really.
No, not really. Exactly. So, you know, I get that you know, my big thing with engineering firms, you know, is I get we don't need to lay out every sprinkler head. It's not our job to lay out every sprinkler head, show the piping on every job. But I think it is our job to just talk about basic obstructions that we know exist on every job. So in the kitchens, does it hurt to put obstructions follow and call out? You know, you can call out a figure in Nfpa, call it out in that kitchen area. Now that covers us. So that way, if something goes wrong and the sprinkler fitter puts the head in the wrong spot, is the end user going to be mad at us when there's a change order? No. Is there going to be a change order? No, because we said to them, hey, we recognize the situation. We said use obstruction figures. You didn't follow it. That's on you as a contractor. Okay? Obstructions vertical coming from the floor up. We do not have to follow that. Remember, it's from the ceiling down, not the floor up. A lot of times I'll get calls from designers and stuff. Hey, I have this obstruction and it's from the floor up. Or it's from the floor all the way to the ceiling. Okay, well now we have to worry about it. But if it's just from the floor, what is the distance down that our obstruction should stop for a sprinkler head? Anybody tell me? If we have an obstruction from a refrigerator or a column that, well, I wouldn't say a column because a column should go from floor to deck. So
8 feet below?
18 inches.
18 inches.
Yep, 18 inches the sprinkler head should, from the deflector to the bottom obstruction. And as long as it's 18 inches or more, then we don't have to worry about that being obstruction.
What about in case of racks, like storage racks?
Yep, we're going to get into that. Yep, then
Still
we got
the same?
No, then it's a little different, depending on what head, and we'll talk about that in a few. So, like I said, right now I'm just hitting the important parts of our obstruction, because we're going to try to cover all different types of sprinkler heads. So here's one here where once again, you know, it's 18 inches down. So now we know we have a situation there where now you're going to have to put some sprinklers in.
Do you mind if we take notes on the phone?
No, go ahead.
All right.
No, go ahead.
I just want you to know we're taking notes on that.
Absolutely, no.
All right.
And when I find my PowerPoint, because I have all this stuff in my PowerPoint,
Right.
when I find it, tomorrow when my corporate office gets in my computer and helps me figure out where it disappeared to, I have all your email addresses and I'll email you the PowerPoint. So that way it also makes it easy. But like I said, for whatever reason, I lost my PowerPoint and I have no clue where it is. So at last night, I was not about to start over because it takes a couple hours to make it. So I figured we'll just go through it today this way. But I will email you the PowerPoint once I find it. So these are, you know, when we get into, you know, we talked about the 18 inches. So if we get 18 inches and down, now we have to look at another avenue. If that sprinkler head is probably not ever going to get under that obstruction, so what are we going to have to do? If it's, you'll see here, no addition is required if it's 24 inches, but keep in mind, if you can't get that sprinkler head over, or if it's 30 inches or more, we're going to always have to put that sprinkler head in, okay? Open wood truss, I don't think how often do you guys see open wood truss inside residential units?
Never.
Not yet. Not
yet. Up north, we see it a lot. So what we do up north is, you know, they take these old warehouses and instead of demolishing them, they'll go ahead and clean them up, and we call it clean construction. So you'll have condos and apartments that have open web joists, that's their ceilings, and then you have the ductwork. So that's where you have to get into worrying about the joists and things of that nature. But down here, I try to keep it to what we need down here. All right, so here's the column that we were talking about. So if we have an obstruction, a column that goes from floor to ceiling, we have to know what the, you have to take 4 times C, 4 times D, okay, one or the other. If it's a square, then you're only going to do one or the other. If it's not a perfect square, you got to take the longest side of either D or C. You got to multiply that by 4, and that tells us how far off the sprinkler head has to be from that obstruction. So if that column will say D is 12 inches and C is 18 inches, what would we do?
418.
We would multiply 18 by 4, that gives us our answer, and that's going to say, okay, that sprinkler has to be that minimum distance off of that column, okay? Fixed obstructions. We're going to see out here in the lab today, what does a fan do to a sprinkler head? You know, so we're looking at obstructions to prevent the discharge of the hazards. Ceiling fans. That is, you know, now granted, once again, us as engineers, most times we don't know what the fixtures are. Where would we come into these fixed objects? You probably don't usually see ceiling fans in kitchens, but where do we see ceiling fans? Living rooms, the bedrooms, right? Bedrooms are common to have a ceiling slash light, or I'm sorry, a fan slash light. You know, so we gotta make sure that, you know, if when we're doing a review, this is going to be more on a review side rather than our engineering drawings, to make sure that, hey, if we now know that there's a ceiling fan there, we got to make sure that that sprinkler head is far enough away. And we're going to see why when we get out to the lab here. Just like, you know, the lights. Sometimes you'll see the lights that are, you know, so this is a flush mounted light. Sometimes we see the lights that are coming down 6 inches, right? So what do we do with those sprinkler heads? When we're working with the electrical department and they have that, we have to drop that deflector down to be even with the light, or you have to go back to that first chart that we were looking at that says, okay, if the light is down 6 inches, we need to be 3'7" off the wall, off that obstruction. All right, so now as we move into 810.7, we're now going to talk about sidewall sprinklers. So before we were always talking about uprights or pendant sprinklers. The most common residential sprinkler head is a pendant, right? Mm-hmm. We do have an upright sprinkler, but it's only listed for certain things. So all the stuff that we were talking to up to now was mostly focused on your pendant sprinkler, whether it's semi-recessed or flat plate concealed. Now remember, we talked about the distance down from the deflector, not the distance down from the sprinkler. So that might also make a difference on when we're specifying, concealed heads versus recessed heads. Because now your deflector is going to be what? If the concealed pendant is installed properly, when that deflector drops down, it's only dropping down about 1/4 inch to 1/2 inch below the ceiling. Where if you're using a recessed sprinkler, you're talking 1.5 inches from the ceiling down. So we got to keep that in mind when, you know, we need to, and that's why it's important, and in my opinion, and this is strictly my opinion from an engineering point of view, is we should be, not shall, because it doesn't say shall, but we should be putting on all of our FP drawings a sprinkler head schedule. Whether it's Viking, which of course I would like it to be Viking because that's my job, but whether it's Viking or whatever manufacturer you're going to use, it's important to, you know, put that head schedule down. Now, if they don't follow it, if they say, if you have Viking as a head schedule and they submit somebody else, well, so be it. But at least the head schedule is going to give you some basic information to know what you're anticipating them to follow. I've had some times where we couldn't, the end user, the architect, wanted flat plate concealed sprinklers, but because there's so many obstructions and so much stuff above the ceiling, I said, look, believe it or not, that ½ inch is going to make a difference in a lot of these rooms, from adding another head to just using a semi-recess. Why don't we go semi-recess and just paint them? So there are times where we have to think about that. All right, so going down to sidewalls, residential sidewalls, you're going to see the same application. So in table 8.10.7.3, this is going to look very similar to the pendant and upright position, where off of A and B, off of the wall. So when we're doing sidewalls, now we do have to worry about the application, okay? So in figure 10.7, we need to know what this distance is from the ceiling down, and then our obstruction. So remember we talked about A and B, it's the same principle, but you're going to notice it's a little bit different. Oh, too far. When you come, no, sorry. I gotta remember not to hit that other button. And the obstructions, the little bit of difference with obstructions versus sidewalls and versus pendants is going to also make a difference on what you really want to do. So you'll see, for less than, if B is 1 inch, less than 8 feet, you can't have that obstruction, okay? You're only going to start that obstruction when you get 8 to 10 feet away. So we're looking at the ceiling. Remember, down here we're going to be looking at the ceiling. When we talk about sidewall sprinklers, the minimum is still 4 inch down from the ceiling. Maximum is 12. There is no sidewall sprinkler that'll give you more than 12 inches down from your ceiling. Okay? With residential or standard coverage sprinklers, there is no sprinkler that will be more than 12 inches down.
Why is not showing the distance from the wall?
Because the distance from the wall, you can be on a sidewall. Remember, now we're looking at sidewall sprinklers. So you can have a concealed sidewall in the wall, or the sidewall can be out up to a maximum of 4 inches. Okay? So your sidewall can stick out of the wall up to a maximum of 4 inches to the deflector, or it can be concealed inside the wall.
I see it right on the wall there, right?
Well, we're looking at this chart right here.
Ah, I'm sorry.
Yep, we're looking at this chart here. This one over here is still talking about our suspended floor mounted for pendants. Just talking about, and we're using the same principle, A and B. The distance up and the distance over. So, these two charts, remember I told you, no matter what sprinkler head we're looking at, that first chart, A and B, the distance, those are the two most important charts in the application. Just like with sidewalls.
So I'm sorry, that elevation view here, that...
Are we looking at this one?
That's the wall mounted?
No, so this is pendant.
No, the other one.
Yeah.
This is wall mounted. Yes,
Wall mounted.
this is a sidewall.
Okay.
Yep. So what it's saying is, if your deflector is 0 distance here, at the bottom of the obstruction, you don't have any requirements. You don't have to worry about it. You only have to worry about looking at this table up here and looking at the chart is, if the sidewall head is here, so if this obstruction is 12 inches or less, we don't have to worry about obstructions.
Okay.
If this is more than 12 inches down, or if the sprinkler head that the contractor is using or the sprinkler that you specify is only 6 inches listed from the ceiling down, that's where you got to know that. Okay, so Viking, all of our sidewalls are 12 inches down. Some of the other manufacturers, I'll tell you, they're only 6 inches. So we got to look at the obstruction and see how far down from the ceiling is the obstruction going, and then where we place that sidewall sprinkler, how far up off of this obstruction is it going to be? If, you know, when you look at this up here, it says not allowable. If you have the deflector even, you're good. If you have the deflector coming up, then you have to be that distance. And remember, it's from the face of the obstruction back to the deflector. Yep.
You just have to follow B and A.
Yep, so we're just following B and A. So let's look here. So if B, right here, we'll look at 9 inches. So if this obstruction was sticking down, and it was 9 inches now from the bottom of the obstruction up to the top, now you'll notice it's the top of the deflector, not the center deflector. If this is 9 inches, that's telling us that our sprinkler head has to be 15 feet less to less than 16. So you got to have 15 to 16 feet here. Now, once again, you know, you're looking at that sidewall, okay?
Well, if you don't have it, what would be the solution? Just lower it?
If you don't have
that 15 feet, if you cannot provide the 15 feet.
Then you're going to have to put a sprinkler head on each side of the obstruction. Yep. You would have to consider this a pocket, and you would have to put it on the other side.
Around.
Yep, exactly. And we're going to see this one too. So the two that we have already talked about, the two most important tables that we have to worry about, we're going to be flowing them out there, and you're going to see, we'll be able to physically see it. If that obstruction up against the wall is less than 30 feet, we don't have to have a pendant under it. That's another big thing, that 30-inch, I said 30 feet, but it's 30 inches. If it's 30 feet, would be pretty big. That would be a pretty big obstruction, 30 inches. If it's over 30 inches, we know we're always going to have a pendant sprinkler and a sidewall. So where we would see that is right here, under figure 10. If the obstruction is more than 30 inches, you're going to have a pendant sprinkler head here, and then you would have a sidewall. This would be on the back wall. So this diagram would be showing the obstruction on that wall, the sidewall sprinkler here. So if you have an obstruction over there and it's more than 30 inches, you're going to have to put a pendant sprinkler, and then you would have a sidewall in the middle here that would go. If it's less than 30 inches, then we can very simply take D minus 8, add B, and we're good to go. If the obstruction is less than 24 inches, there's no maximum, because once again, we don't need to worry about that sprinkler head underneath. So what this chart is, and I apologize, I kind of said that backwards to you guys. If the obstruction is 30 inches or more, if you can get this equation right here to work using the chart over here, okay, using this chart over here, you would not have to add a sprinkler head. It's if you can't get this equation to work. All right, kind of the same thing. Now this is an obstruction. Now we're looking at 810-714. This is, once again, now we're getting into these soffits and these cabinets. Okay, so we need to know how far off that wall it is, and so on. It's still the same thing. You know, one thing about Nfpa, it can be kind of, in my opinion, when I first started using it a lot, is if you don't look at these charts a lot, they can get very confusing. Okay, but you're going to notice that AB is 90% of what we're going to be following on all these different applications. All right, so now let's look at light fixtures and all that good stuff. So here we have the obstruction, you have the sidewall sprinkler, we have obstructions with the horizontal orientation. So once again, what do we got to do? We got to make sure that, you know, and really this is the sprinklers, this is, once again, getting into this one here is really the designer's responsibility to make sure, but from an engineering point of view, it's our job to review their drawings if we know it's going to be there, okay? We do the same thing with the obstruction if we have a column, okay? For column protection, you're still using 4 times C or D, whichever one is larger.
One more question. Now we're doing a residential. What section of the Nfpa is that?
So this is for residential sidewall or residential sprinklers. It's all obstructions are under 8.10. So it's 8.10 for all residential, and then
High-rise building.
Yep, and it's going to be 8.10 for 13R too. And then 13 has its own chapter, which is, I forget. But in 13D, 13D has its own chapter.
For okay, 8.1 is for residential and for commercial.
For NFPA 13, 8.10 is covers all of your obstructions for residential sprinklers.
8.10.
8.10. That's going to cover your sidewalls and your pendants.
And commercial. And commercial?
No. Nope. 8.10 is strictly residential only. We're going to get into commercial sprinklers in a minute.
Right.
Okay?
So what's the difference between 8.1 and 8.10?
So, your basic requirements of a sprinkler system, of sprinkler heads in any type of unit. It doesn't deviate from residential, standard coverage, or anything.
I see.
Okay?
8.10 is residential.
So 8.10, you'll see here, when you're looking at NFPA online, if you go to Chapter 8, the installation requirements, you know, you'll come right down, you click 8.10, and 8.10 will give us, you know, what we just went through.
What will obstruct?
And this is, remember, this is strictly residential, which is what we were going over. Let me just make sure there's nothing at the bottom of that, and then we'll switch out.
So they don't differentiate between a high-rise building, residential, and lower-rise building?
Nope.
So it's the same.
Yep. The same obstruction rules that are in NFPA 13 apply to 13R as well. Yep. You're gonna find the same information in both. Okay. So the last chart that we wanted to just touch base on is very similar as well to the pendants. Just the only difference is your A and B is a little different numbers. You know, for your sidewall sprinkler, we're going to an obstruction coming up from the floor. Okay. So the big thing to remember with residential is going from pendant and uprights, which is really mostly all pendants. So going from pendants to sidewalls is your B is a little bit more restricted when you use sidewall sprinklers. Okay? Because remember, the sidewall sprinkler needs to throw out past that obstruction or has to get underneath. So that's why your obstructions are a little bit more stringent with a sidewall sprinkler than what a pendant sprinkler would be.
Sorry.
Yep.
This can be, not should be the top of the...
Nope, so now they change it. When you're working with sidewall sprinklers, the residential sidewall sprinklers, when you have an obstruction coming down from the ceiling, you measure from the top of the deflector.
Yeah.
When you have an obstruction coming from the floor up, you're going center line. Yep, so no, that chart's right. That's just something that we got to remember when we're doing obstructions. Where do you measure? And that's what's important, you know, when we're going through these. Is I don't expect anybody, because I'll tell you now, I can't remember A and B with all the 4 inches down and this many feet away. That you're not going to remember. What's important to take out of this seminar is how do you use the code to find the situation that you have, and then go out and actually flow some water to actually see why it's important, you know? The best part of today is outside. So, any other questions with residentials? We kind of went through all the different obstacles that you're going to see in the residential units or apartments or hotels. What we'll do is let's go over for the purpose of time. We'll come back to 8.6 and we'll just skim through that real quick. So 8.6 is, you'll see on the side here, 8.6 is, well, let's just take a step back for a second. 8.1, like I said, Chapter 8 is going to cover everything that we need to know in Nfpa 13. Your basic requirements, all that's pretty much doing is telling you your basic, for light hazard, maximum spacing of a sprinkler head, 256. Ordinary hazard, it goes through all that. Your limitations are going to give you your system limitations, not your sprinkler head. So your system limitations are down here. So Chapter 8 is what you always are going to be pretty much referring to when you're reviewing a drawing from a contractor. This is our primary chapter that we're going to be following. And I just messed it up again. So 8.2, when we need to decide how many risers should there be, if we have an incoming water supply and we need to break this into zones, how many zones in a building should we have? It's real. If you go to 8.2, you're going to notice light hazard, one zone of a wet system, of a light hazard, wet or dry, you're going to have a hard time making 52,000 square feet work to get your water delivery time. But light hazard is 52,000 square feet. So you know if you have a building that is 52,500 square feet, how many separate zones do we need? Two, right? Yeah. Because the maximum is 52,000, and so if we go 52,500, we're over that maximum allowable spacing. And you'll see ordinary hazard, extra hazard. When we get into storage, it gets completely different, and now we got to go into the storage applications, because storage applications goes by how many sprinkler heads flow versus an area. In my presentation that I have, I have one slide that talks about all these chapters, and I should have started off with that. The use of sprinklers is 8.3, and that's just going to tell you when you should use what kind of head. A basic guideline. It's a basic guideline, upright versus sidewall versus bendant, a dry sidewall, things of that nature. Yes.
Hey Brian, I don't want to throw you off your rhythm, but
go for it.
Do you mind touching on early suppression, fast response sprinklers?
Yep. So we can. Yep. That's exactly what we're getting ready to go into next. And then when you come down here, once you get out of there, it's the positioning. So now, the next one would be, I did residential first, and on my PowerPoint, I go residential, standard, extended coverage, and then storage. But we can kind of skip, because if we go to standard pendant, let's go to 8.6. Here's important when we get into, when we're using, because usually the skylights and stuff are going to be out in hallways and stuff. So keep in mind, skylights, here's your requirement for obstructions with skylights, okay? It's real easy. It spells out exactly what you have to do in order not to have a sprinkler head in there. If it's sprinkler head's required, then you got to put that sprinkler head in there. And we're going to go over that in the lab outside. But my point is, with standard coverage sprinklers, it gives you a little bit more information. But when you scroll down through here, you're now going to start seeing a little bit more diagrams, okay? So here's where we see this a lot. Where would we see this where we're going to possibly use this, a lower ceiling and a higher ceiling. In our high-rise buildings, like I said, most of our high-rise buildings is multi-use. So where would we, what area of the building are we going to see this?
Always.
Hallways. When you walk down hotels, hotels love to do that slow ceiling, and then right where the 4 rooms are, or where the rooms are that jump up, you know, where you enter the hotel rooms, they put a higher ceiling there so they can put the higher doors. And then once the doors are done, they drop back down and they go low again. So here's where we're going to be able to see, this chart right here is where we, as a sprinkler designer, needs to use that chart to do...
Would you apply that to a cloud application?
No.
No? Okay.
The newer editions of Nfpa 13, the clouds are completely separate. They're starting to get into their own chapters, because clouds, you got to know, for a clouded ceiling, you need to know how far off the wall does the cloud start, how wide is the cloud, and then what's the separation from the cloud to the next cloud. Because a lot of times you might have like them small clouds, you know, so there's a lot of different avenues with that. Is it obstructed, or I'm sorry, is it combustible, non-combustible? What's above it, what's below it? So clouds is not in chapter 8. It'll briefly talk about it, but not much. And then you're going to notice that, you know, with standard sprinklers, you're going to get to the same charts as your 13R would. Just remember, the numbers are a little different. So don't get confused between, because you see the same chart, you can use the same numbers. A standard sprinkler, extended coverage sprinkler, has different, your A's and B's, okay? Attics, you don't really sprinkle attics down here, right? So we'll skip over that. And now, don't all these charts look similar? Yeah. Like I said, the difference is the numbers. So don't get confused between, don't think we can take an obstruction for a residential sprinkler and use the same numbers for a standard coverage or an extended coverage, because you can't. You got to use, and that's why it's important in this class, is just mostly to know what these different views are trying to show us, and why it's important. That's the whole point of today's class. So you'll see, once again, you know, you got your floor-mounted obstructions, your ceiling-mounted obstructions, and all that stuff. And then it gets into the sidewalls, just like all the other heads do. So for time, we got about 20 more minutes before we go outside. So storage is a big thing, right? So let's go into storage a little bit. Is everybody good with the way Nfpa 13 shows the obstructions and how to read the obstructions?
Very good.
Yeah. Are we good with that?
Very clear.
Okay. Now you're going to notice when we get into, let's go into storage facilities. You're going to notice in chapter 8 here, you're going to have to know which sprinkler we're going to use. You have CMSAs, control mode specific applications, okay? That is not an ESFR sprinkler. Control mode specific application has a lot less obstructions than an ESFR system, okay? Then you have the ESFRs. Then we have in-racks. What's the obstructions on an in-rack? How do we protect the in-rack sprinklers? So it's very important to know from an engineer, what are we going to specify when we get to storage? If we're going to stick with ESFRs, we have to plan that, because that's going to be a big deal. Like I said, a lot of times I go into engineering firms and they'll tell me about all these obstructions, and they'll say, it just seems like an ESFR won't work. No, you're right. Let's go back over to control mode specific application. Fortunately for Viking, I can push engineers to do that, because we have the most available CMSAs. We have a 19.6 that will not require in-rack sprinklers and all that stuff, that has all the requirements less than your ESFRs. So here at 811, you'll see right here at the bottom here, 811 is going to start our CMSAs, control mode specific application for storage applications. Let's scroll up a little bit just to make sure we're not missing anything up here that we want to talk about. We talked about area of sprinklers, you know, for commercial and all that stuff. So we had the same thing here. Okay, depending on what you're protecting, you're going to notice the protection area is a maximum of 130 square feet or a maximum spacing of 12 by whatever. Okay, so the spacing on the branch line can't be more than 12 feet. So you can go 12 by, to get up to a protection area of 130, we could do what, 12 by 11? 12 by some, let's see.
1122.
Yeah, so there you go. But this chart's going to tell us, if we're doing CMSAs, what is the maximum distance on a sprinkler head, on a branch line, I mean. What is the distance between the sprinklers on a branch line? And then it's going to go down into, you know, the different types of obstructions. Is it rack storage? Is it combustible unobstructed, non-combustible unobstructed? That's where you're going to get your maximum. So you're going to see when we get into rack storage, if you're using a CMSA, 10 feet is going to be the maximum distance on a branch line. The spacing of the head. Then you take it out farther. So here you have 100 protected area. 100 square feet. So we know the maximum spacing on the branch line between heads is 10. So we know that the most we can go to the next branch line would be 10, because 10 by 10 is 100, right? That one I can get without doing the math real quick. I always check myself, because I've done a couple times where I just spelled out something, right? And they're like, your math is off. All right, you get my point, right? You know. Distance from the walls is going to be very similar, you're going to notice, to residential sprinklers. And why is that? Why? You're going to notice when we're talking about distance from walls, distance from obstructions, the theory is very similar to residential sprinklers. Can anybody tell me why that is? Because residential sprinklers and storage sprinklers, whether it's CMSA, ESFR, those sprinklers all require fire tests. Okay? So, and any residential sprinkler head that a manufacturer comes out with, we have to do a live fire test to prove it. Any storage sprinkler, whether it's CMSAs or ESFRs, we have to do a live fire test. So, with a standard coverage sprinkler, you know, they just give you basic 7 feet, maximum 7 feet, no matter if you're going 225 or whatever, you know. Here, we're always going to give you, you know, it's always going to refer you back to a manufacturer, and then it gives you the minimum. Okay? But it's, you know, you'll see it says 1/2 the allowable distance permitted by the sprinkler. Where do you find that information? You go back to the data sheet of the sprinkler. Minimum distance off the walls is always going to stay the same. Once again, 4 inches. You're going to notice A and B again, right? So this is going to be for, you know, your obstruction rule down here with the CMSAs. A lot of your CMSAs will allow you to be, you know, where would you, when we get into warehouses, so how do we determine if we're going to use a CSA, a CSMA, or a ESFR? How do we determine that from an engineering point of view? I'm assuming we all do storage facilities?
Mm-hmm.
So how do you guys make a determination right off the get-go if you think you're going to go with an ESFR or a control mode? You guys just kind of throw it out there and throw a dart at the wall and hope that it sticks?
Most of the time we have a system that installed already, you know, just when.
Okay. So there's not a whole...
have to deal with it, you know.
Right, okay. So some of the options that you know, that I say when we're looking at a new warehouse being built, how do we determine if we're going to go CMSA or ESFR? For the longest time, everybody thinks, oh, ESFR, as soon as you hear the word rack storage,
ESFR.
ESFR. That's what we got to do.
Oh.
Always. but that's not right. So what we got to do is we got to look at the rack storage height and the building height. That's the first thing we have to look at. Then what we need to look at from an engineering point of view before we go to an ESFR is what is inside the building. What are the joists? Are they open joists? Are they solid joists? Are they solid beams? What are they? Then we need to know what is our method of our discharge for roof drains, your water drains. 9 out of 10 times, if you have a building that's going to have roof drains that are going to be drained inside, that means you're going to have 4-inch or 6-inch CPVC running through the ceiling, and then it comes down, then it'll run over to a column, drop down to a column, and then underneath the building, right? Well, depending on how big that building is and how big that pipe is and how many roof drains there are, that is an obstruction for ESFR sprinklers. So if you have a lot of that, now you might say, wait a second, is it worth doing ESFRs? And then let's take a step on top of that before we decide ESFR. So we have a building, and on this building here, it's going to be roof drains, and we could probably have, because it's a rainy area, the engineer, they built the roof on a lightweight construction, so you can't have a lot of water on it, so you got to double your roof drains. So this building is going to have 30 roof drains on it, and it's all going to be dumped in through roof drains going through the building. Okay? Now we got to look at the lights. What kind of lights? Are they suspending the big, bulky lights that, or are they doing LED kind of like strip lights?
Most new buildings are LED.
So, but is it the strip lights or is it the big, bulky, round lights?
Strip most of the time.
Okay, well that's good, because if it's a strip light, now we can...
It's not obstructing, basically.
Exactly. If it's a strip light, we don't have to worry about the obstruction requirement because they're going to be down and far enough that they're not going to obstruct an ESFR. But if they're still using them big, bulky, round lights with LED bulbs inside of them, 9 out of 10 times that is an obstruction to an ESFR. So now you got to have extra ESFR sprinklers on each side, one on each side. Now you also have the drains, so on. And then if you have your bar joist, the sprinkler head, the ESFR always has to be a minimum of a foot for an ESFR sprinkler head away from the center of the bar joist. Control mode sprinklers, we're going to see, you can be 4 inches away. So if you have bar joist and you have all these obstructions, what would be the better method from an engineer? Are we going to specify an ESFR, or are we going to specify a control mode when we know that you can, as long as the height of the building and the height of the storage allows no in-racks, because the whole secret is no in-racks. Yeah. That's what we want to. That's what we want to give our end user, right? No in-racks. So that's something that we got to think about. We need to know some information prior to coming and looking at the obstruction rules. Is okay, what is it? Because we know that the ESFRs has a lot more restrictions. So here you're talking about the open web joists, specifically with the 19.6 from Viking, it is listed to be 4 inches off the joist. So your line of sprinklers can be 4 inches off. That gives you a lot of protection. If you don't, if the CMSA, if the manufacturer doesn't give you a specific distance away, now we have to follow this chart here, okay? So we have a 14.0, a 16, and a 19, and there's one other one I'm missing. But we have 4 CMSAs. One of the CMSAs, our 19 K factor, our K19, says 4 inches from the joist. Our other ones don't tell us because we didn't test them to that. We didn't care. It didn't really matter. Just like the other manufacturers, they didn't test to it. So here's where we're going to follow this here. So once again, you're going to take now 3 instead of 4. You'll notice it's 3 times C or D. Okay, however that joist is built. Most times it's going to be D because it's steel, so it's pretty flat, and then the bar joist in the middle. So most times you don't have a block there. It's the width of the joist is what we're worried about. So you got to take D and multiply that by 3. unless the data sheet is specific and says otherwise. If you're going down directly below, we have that, and I missed, somebody asked me earlier about distance down from the ceiling. And under the obstructions, it's going to tell us, I think I missed it already. I just remembered somebody asked me about that. Unobstructed construction, you're going to be 6 to 8 inches maximum, and then obstructed construction, you're going to go down to 12 inches. Okay? So somebody asked me earlier about storage sprinklers with distance down, is it the same? I think somebody was asking me that.
Yeah, right, from the top of the rack.
Oh, so you were asking from the top of the,
Of
so
the
you're
rack
going,
to the sprinkler head.
okay, rack to the sprinkler head, so we didn't get to that yet. We're still, so once again,
Yeah,
these charts are
sure,
just still going from the ceiling
From
down.
the ceiling
okay?
down.
But you'll notice, all these charts are the same. Once you know how to read the charts, it's all about just knowing what sprinkler head you're using, okay?
Exactly.
36 inches. So 36
Big
inches from the bottom of the sprinkler to your storage, okay?
Give you some credit because the racks are open. They're not solid.
Right, so remember, it's 36 inches from the top of storage.
Right, from top
Yeah,
of
you
the rack.
don't, not the top of rack.
Top
They're
storage.
Oh, top of the.
Storage, because the storage,
Could
think
be
about
higher.
it. Right, sometimes they'll, on a rack, they might, that top shelf,
Oh, yeah.
they might put 8 feet on that.
I know.
If that rack can hold the weight of 8 feet worth of merchandise on that top shelf,
That's clearance.
so it's clearance, correct. 36 inches down from the deflector to the top of storage, not top of rack. Yep. All right, so now we get into 8.12. Let's go down a little bit farther. I don't want to mess this up here. So there it is there, 36 inches. Over there you'll see 8.11.6. Remember, it's storage. It doesn't talk about the rack itself. So now going into early suppression. So these are going to talk the same difference, but now we're going to get into, remember, when we get into ESFR, all ESFR sprinklers have mandated a certain, so let me step back. Control mode specific application, we're going to say, we can either say one or two things. It should be designed around a remote area at a certain pressure and a certain flow, or a specific flow at a specific pressure for the specific head. When we get into ESFRs, we're going to, all ESFR sprinklers, the code is going to say a minimum of a certain amount of heads flowing. Usually it's going to be about 6 to 12, okay, somewhere's in there. And it's going to say a certain PSI. So I want you to flow a K22, we want, and it's a certain type of commodity. It would be, 12 heads, and we want 50 PSI, or we want 30 PSI, depending on what the commodity is. And that you're going to go back to NFPA, you're going to go back to Chapter 12 in NFPA 13. Chapter 8 is once again, oh, I did the wrong thing again. Apologize, guys. The maximum area coverage is going to be, 100. They say not to exceed 110, but most of the manufacturers are going to give you a specific of either 100 or 80. Okay? This says 110, but don't follow this because 90% of the manufacturers have a maximum of area of coverage of either 100 or 80, depending on the commodity. Now remember, when we get to storage, we're not talking about a hazard, we're talking about commodities.
Yeah.
What's being stored inside the application. So you're going to notice here, 12.2.3, it's going to give you all your information about, I remember I said to you, 1 foot off of the joist, okay? So you gotta be, you gotta make sure that that sprinkler head meets your requirements that you're off. So here's a good chart. We were saying distance, so from the top of the storage, remember top of storage, depending on your application, it's not less than 18 inches, but most times it's going to be 36, and then your obstruction. So this is really following an obstruction rule. So you got the head's up here. Yeah, let me get my thoughts here again. So we have the sprinkler heads up at the ceiling level. We have our top of a storage.
And you have an obstruction as well.
And we have an obstruction below. So you'll now notice that the maximum obstruction, what kind of obstruction could this be?
Choice.
Light fixture.
Could be a light fixture. If it's a environmental, or if it's a conditioned building,
Yeah.
what is that?
Duct.
Ductwork.
Mm.
Okay, you do see some of these warehouses being conditioned.
Oh yeah.
So this is really looking at ductwork, okay, or large trays, cable trays. You know, if you're going into a facility that has a lot of cables and trays running through it, that's what you're going to see that. So the maximum obstruction is 24 inches, or you have to have heads on both sides. You can't have the obstruction closer than to the top of storage of 18 inches. And then overall, you're still going to meet that 36 inches from the ceiling down to your top. So you got 24 and not more than 18, okay? And then the sprinkler, we got to take the distance between the sprinklers, divide it by the spacing, and then we got to make sure that that sprinkler head, what that's telling us is the sprinkler heads, when you divide the spacing, it has to be about center line of that obstruction. So the two sprinklers will flow underneath of that obstruction, if need be. And that's actually CMSA. I don't know what happened there. Why did I get out of ESFRs? I must have hit the wrong button there. All right, so we're back in ESFRs. Once again, this is giving us all the same information. Distance away, your A and B. Obstructions near the ceiling, which is going to be an important part for ESFRs, 8.12.5 all the way down, so 8.12.5. Here's where we talk about what we were talking about with the light fixtures, all the things that can be in a ceiling below a sprinkler. You'll notice with ESFRs, it says that you need to isolate the non-combustible obstructions. You need to install, sprinklers shall be installed below them. So with ESFRs, as I was saying in the beginning, when we get to storage sprinklers, you might have 2 or 3 layers of ESFRs. If your obstruction is more than 24 inches, you have to have, and you can't get the spacing, you know, half the distance. You know, if it specifically says there that you shall have a sprinkler below. Then when we get to, here's another good one. So 8, the continuous obstructions below sprinklers. Okay, this chart right here, or this line, these line items. 812.5.3 for ESFR, the general continuous obstructions. Continuous obstructions would be what we were talking about, your ductwork, your
cable trays or whatever.
yeah, your water discharge coming through. So depending on how big and how wide they are and how deep they are, is going to tell you whether or not sprinklers need to be added or not added. So you'll see on number 3, additional sprinklers shall not be required if the object is 1 foot or less in width and located a minimum of 1 foot horizontally from the sprinkler. The secret with ESFRs is 1. Okay, if when we're talking about obstructions with an ESFR, it's always 1. 1 foot away, 1 foot, usually everything's by 1. You know, if you're closer than one, you got to put extra sprinklers. If you're farther away than that, you're good. You'll see even there with the bottom of the joist, you got to be 1 foot away on 81253. Here they're going to actually talk to you about the conduits, ground pipes for that to be considered. They all have to be 3 times the width adjacent away from the pipe. So, you know, you got to make sure you follow that. Like I said, ESFR is a big thing about taking away from ESFR. As you notice, compared to a specific control specific, you're going to have to see a lot more obstructions in here. So, control mode specific application, we always want to kind of look at when we get into all these different types of obstructions. What are some other items? Depending on, you'll notice here 12.6, you still have to have 36 inches or greater, depending on what the distance is, and that's going to depend on what ESFR, what K factor ESFR are we following. Okay, so you got to go back to the manufacturer and look at their ESFR and see what their tested requirement is. But it should always be a minimum of 36, and if the manufacturer requires more, then we need to do that. I feel like I'm missing something really important to talk about with ESFRs, and I can't. I was hoping it would pop out at me. Go ahead, somebody have a question?
Yeah, I have another question, but
Yep.
I don't know. Where can we find the design for the water pipe, the size?
That's going to be done on your hydraulic calculations, and that's another. That's the hydraulic calculations that are.
Another department?
No, the designer and the sprinkler contractor is going to pick that, and that's important to know too. That's a good point, because if you're when we get into ESFRs and control mode sprinklers, it tells you in here if the pipe is larger than 2 inch, the deflector has to be so many inches above that, because with an ESFR sprinkler, if you have if you are actually it's 2.5 and larger. So 2.5, a lot of times you'll see that ESFR in a pendant position attached to it, but if it's an upright ESFR, you have to start raising that up. You can't have the sprinkler head attached directly to the pipe. If you go 3-inch pipe, you got to move that up a couple inches. You got to have a little nipple with you know. So the size of the pipe, that's done by the hydraulics, because remember each ESFR or control mode specific application is going to tell us a certain pressure and a certain flow, a certain amount of sprinkler heads.
So there is no specific standard set by Nfpa as to...
No, because we also got to look at the commodity. Every commodity is different. You know, if you have a commodity group 1, you might only need 20 psi of pressure. If you get to a commodity group 4 and then you get into plastics, now you need 50 psi. And it also, the tables in also depend on the height. If you're only looking at a 30-foot high building and 25 foot of storage, you know, your K14 is going to be less demanding than the K25 or 26. You know, now we're going up, we got listed up to 55-foot high buildings, 50 foot of storage, using a K28. So that's going to be even more demanding, so larger pipe, of course. You know, so pipe sizes, you don't really, as an engineer, unless you have a hydraulic calculation program, I would never recommend putting a pipe size on the drawing. You leave that 100% up to, our job is to make sure that we cover obstructions, we cover the basic of the design, but when you get into this requirements of pipe size and stuff, you don't ever want to put that on the drawing, because if you specify a pipe size and it's wrong, they're going to get you. Of course. So, pipe sizing, I tell everybody, don't get involved. That's the designer's job. Figure out what pipe size. We need to focus on just saying what the commodity is for storage, what the commodity is, what head are we recommending to use, and the basic and the basic positions of them. And that's all we want to stop at. Yep. Any other questions? All right, let's go head out and let's go flow some water. That's going to be the fun part. We have heads installed 6 inches down, and then we have the sprinkler heads installed 12 inches down. Then we have, if you have the obstruction on the same wall, we're going to notice that this sidewall sprinkler head will never protect underneath of it. So that's why under that obstruction rules that we were talking about with the A and the B, it says you need to put the sprinkler head in there if you're using sidewalls. The distance, here's that obstruction, remember we were talking about, so far away.
Yeah.
So we're going to notice when we flow these, at 6 inches, this obstruction is not going to work. 12 inches it will, okay? Over here, we're going to flow these heads, and this is now an obstruction where what this represents would be maybe, you know how sometimes you have the cabinets go all the way up to the ceiling? Other times you have your cabinets that stop halfway, and then it makes it like a shelf and people put decorative things up there. Well, that's also an obstruction because depending on how that's installed, that could possibly affect the spray of the room. All right? Then we're going to come over here and we talked about the obstruction with lights and fans in the standard. So we're going to operate, you know, when the head is too close to a fan or too close to a light, and then we're going to show the head being installed properly, the proper distance away. All right? Then let's see here. Up here, so that's the fan and light, sidewall. So up here we're going to show a attic sprinkler. You guys don't really do attic sprinklers, but just for the fun of watching it, we'll throw one out. Over here, we're going to look at this door. So down here in Florida, from what I understand, you guys have a life safety code where you can put a head at the door and protect the doorway and maybe not sprinkle the whole area. I've never actually found that, so I don't quite know what it talks about. I know they have the same thing in New York City and Chicago, where if you have an old building, they're going to make you retrofit, and they want at least a sprinkler head at the doorway to protect the doorway so people get out. So that's what we're going to show there. And then over here, the newer code used to say, well, the old code used to say you have to have a head on each side of the vertical duct in a closet, right? So you would have 2 heads. Now, the newer codes, we've proven that if you have a closed-in environment like this, so there could be a door on one side, but this would be, let's use this as your furnace, okay? And you have your furnace and you have your hot water heater in a closet, you shut the door. This is representing the obstruction of that, but we're going to see that we've proven over the years that you no longer need a sprinkler head on both sides, because this one sprinkler head is going to flow and bounce off enough that it's going to protect the floor and the whole area. Okay, but the older codes would say you need a head on both sides of that furnace or that hot water heater. Then we're going to come out here. So this is now our corridor in the hotel, right? So we have where you got the pendant sprinkler down low, and then this would be like where the doorway is to go into your hotel rooms where they step up. So you would have the head up there, and you'll see that in residential code, if you use residential sprinklers, you have to put a head up in the ceiling pocket. So keep in mind when we're doing specs, you can utilize residential sprinklers in the entire floor. Just because it's a corridor does not mean that you have to use standard sprinklers. However, the difference is if you use residential sprinklers in the corridor and you have a stepped ceiling, you know, pockets, the residential sprinkler head has to be installed in every pocket. If you use a 5.6 commercial sprinkler, you only have to put them down low as long as the pocket above doesn't meet a certain square footage. So that's what we're representing here, is reminding people that if you use 13R, you have to have a head below and above, no matter what the square footage is. if you use commercial sprinklers in the hallway, and depending on what the square footage of the elevated area is, you can get away from not using a sprinkler. All right. Now I know a lot of our buildings down here in Florida are not made out of wood. So if it's concrete and stuff, then you don't have combustible concealed space. But we still kind of get this idea where you can kind of get the idea of an ESFR. We can kind of look at this as an ESFR as well. Remember, when we get into the storage applications, you have to be 1 foot. And why is that? Because that's center of 2 joists.
Yeah.
Usually the joists are 2 feet on center for a warehouse. So if you put the sprinkler head in the dead center of a joist, you're going to be able to flow through. Where if you have it too close to the joist, you're going to see the obstruction. So we're going to flow then, is just so we can see the obstructions. All right, so I turn the fire pump off, so we're not going to be spraying as deep. Might get a little wet, but you don't have to go in the room. We're going to start off inside there first. This one here is our 6-inch parallel to the socket. So you're going to see with that sprinkler head up, if you look at the soffit over here on the side, it's not getting underneath of it on the right-hand side. We got a problem. That is a true obstruction. We're not wetting underneath, and that looks like that's more than 30 inches wide. So we would not be meeting the obstruction requirement. We're going to see now it's getting a little bit more underneath, but it's still not quite doing it. So in this situation, the proper installation would have been to put a head underneath of that obstruction. Okay? See the pendant installed. So now let's go with the pendant under the tab. What I'm going to do, I'm going to turn the sidewall off first, and then we'll fill them both at the same time. So you're going to notice now with the pendant underneath, we're doing 2 things. We're now wetting the countertop where the oven is and all that, and we're also now getting underneath on the floor of that obstruction. So if we have the proper installation on this situation would be a pendant below and a sidewall up high. So now we have that full kitchen fully covered. Yep. We have it flowing out and we have it underneath. Alright, so now we're going to go perpendicular. We're going to So here, by moving the sidewall in that kitchen, we now have the proper space and throwing underneath that obstruction. So now we're getting, you'll notice we're getting on the countertop and we're under that obstruction. So instead of having a sidewall and a pendant in that kitchen, if we would have known our obstruction rules, we could have just had one sidewall off to the side and not have to have that second pendant underneath. Okay? This is the proper installation. You have 2 choices. Add a sprinkler head if the sidewall is already installed because we didn't test the obstruction. But hopefully we caught this properly in our review of the drawings. And we said no, that head needs to be installed over here. Now we don't have to add height. Now you're going to notice with the 12-inch down, this is kind of want to even do more because now look, the 6-inch was okay, it was working, but it wasn't getting nearly as much on that cabinet.
So you can get away with this one and the top one, eh?
Yep, yeah. The 12-inch, we're showing this as 12-inch because Viking, all of our sidewalls are listed as well. The other manufacturers aren't. So why do we show it this way? So that way you guys understand why is it important to specify one manufacturer or another? Other manufacturers can't give the 12 mil down, we can. So, working with you guys, there's a reason why we ask you to specify like this as well. Now I understand not all kinds of things do that, but when you have the opportunity, we're just showing you what the difference is between manufacturers. This happens like it is. We don't want to do that. We might want to say 6 inches. But now you notice, yes, it's still spraying the water, but what is it doing? It's hitting the top of that obstruction, and it's reflecting the spray a little different. So you're getting dry spots in the center of the room. So, you know, it's important to know as a review.
That's the 12 inch.
That's 12 inches down, yeah. Both of them technically will need code, but if you have stuff stored on top of that, you might have a problem. You know, and you see it does have some dry spots.
Right.
But it wouldn't meet the code, it would allow you to you're going to notice if you stand over here, it's covering this side of the fan, but if you walk on that side, the fan is interacting with the water spray, so the corner is not really getting wet like it should. And then the same way on this side with the light, it's pretty much a dead spot. So if we look at our obstruction rules and we know A and B, and we follow that A and B, and if we get the right distance away from the fan and the right distance away from the light, now we got one head and it's flowing under both and the whole room's getting covered. So this is the A and B with obstructions from the ceiling. The door to the field sprinkler, and you see how what it's doing, it's making a curtain here for the door to get people out of the door. Here's our semi-recess. So it's going to cover the door, it's going to cool the door down and allow people to get out. Alright, so those are the 3 applications that, and like I said, I haven't found in the Florida code where they talk about this, but supposedly it's in the code. If you guys know where, I'd love to know the fire code in Florida to know what they're really talking about here. But these are the, per the fire code, if you're doing a retrofit and they require this, these are the only 3 applications you can do. Okay?
So basically this is spraying the hallway, the exit hole.
Yep, it's protecting the
The path.
doorway to cool the doorway down so somebody can get out of that apartment or a hotel or condo.
Now you gotta stay back.
Alright, so we're going to do that, well no, we're first going to do inside that door.
The duct.
Yep, the ductwork or the AC closet.
That's only one, right?
Yep, one head in there, and this is where we prove that by only having one head, it's going to wrap around and start wetting the other side. Now, if this was also, remember, in a real life situation, you would have a solid wall, solid floor, so it wouldn't be draining out. It would start to build up inside the closet. So you see how with a residential pendant, it's spraying out and it's not going to get up in there. So if you have a residential pendant, you need to have above and below. So what I'll do is I'll also put it up in that sidewall. So if you remember, if you're using residential sidewall or residential heads in the corridor, if it's a flat ceiling corridor all the way down, you don't have to worry about obstruction. But if you're using residential sprinklers and you got the step ceiling, you got to use residential heads up and above too. If
you have many of them, you can have one in each.
Yep, yeah. If you're using commercial sprinklers, then you have the potential of not using them up as long as it doesn't go over a certain square foot. All right, this one here is just the attic sprinkler head. Like I said, we don't really do a whole lot of attic sprinklers. You can walk in, it's meant to hit out and then run down the piece of a roof. Like I said, I know we don't do this a lot here in Florida, but it's kind of nice to still give you that idea. So first let's do what it looks like when it works right, when it's installed properly. You'll notice that the joist is being wet and the water is going around the joist and it's being sprayed throughout the area, right? On all four sides. You're getting water out all four sides. Now you're going to notice when we do the obstructed one, because we didn't follow the obstruction rules, it's going to block. And now you're not getting wet on that side, right? The joist is blocking the water, so now you don't have a full spray pattern from that sprinkler head. Because it's bouncing off and just hitting this area. It's still going to get over there over time the longer it sprays water, but it's still obstructing. You're not getting the full spray pattern out of the sprinkler head like you should. So you can look at this as being whether it's an Esfr, a foot off of a bar joist, or you can look at this as being busted complete space, which you guys don't really deal with a whole lot. How many buildings do you see built made out of wood? Right. So South Florida is pretty much done, right? So this would represent, you know, yeah. But it's still good to kind of have an idea, you know? All right. Did we cover everything that you were looking for?
Yes,
Was the class what you were hoping for when you saw obstructions?
Absolutely.
Definitely.
Okay.
Absolutely.
Because I also like to hear the negative. If there's something negative, please tell me so I can fix accordingly, you know? Please reach out to me and let me know.
Thank you.
All right, thank you.
Thank you very much.
Thank you. Yep, thank you for coming. Thank you for coming.
Appreciate it.
Yep, thank you.